Welcome to Machine Coding Interview. I am Sanjay, and in this chapter we will discuss strategy design pattern. Now let's see what is a strategy design pattern. So, according to the definition of strategy design pattern defines a family of algorithms which are interchangeable. It allows a client to choose an algorithm from a set of algorithms at runtime without modifying the client's code. Means, according to this definition, there will be a set of algorithms like quicksort, merge sort, heap sort, and bubble sort. And these algorithms are interchangeable. So the client will have to just pass two things. One is the parameters which needed to be sort, and second, the sorting name. And the rest of the things will be taken care by the algorithm. So that's what it is saying, that it allows a client to choose an algorithm from a set of algorithms at runtime. So this pattern is useful when you want to decouple the algorithm's implementation from the client code that uses it, enabling the flexibility and extensibility. So strategy design pattern provide us the flexibility and extensibility. How flexibility and extensibility? So we can extend our application, like we can use multiple other sort, and the client don't have to worry about how the sorting algorithms perform. He just have to pass this sorting method name, like which sorting should be used, and then rest of things will be cared by the algorithm. When to use? So when we have multiple ways to perform a task, like in any game application, there may be different ways of choosing a player. There may be a round robin way, like the next player will be chosen or a random player will be chosen. So then we can perform this task. Or so in a game application, a player choosing a strategy. In a payment application, the payment method strategy. Or in a sorting algorithm, the sorting strategy. When we need to switch algorithms dynamically at runtime. So at runtime, if you want to change the algorithm. When we want to avoid conditional statements. So without using a strategy pattern, we will have to keep adding if and else statements or switch cases for changing the behavior of the application. But if we are using a strategy design pattern, then we just have to pass the name of the strategy, and then that strategy will use its own logic. When we want to isolate the algorithm logic from the client code. So here the algorithm logic will be separated and encapsulated in its own unit, and the client code will be separated. Examples. So there are many examples of strategy design pattern. First is payment strategy, pay via debit card, credit card, Bitcoin, or UPI. Then in any game application, a player choosing a strategy like round robin selection, random selection. In any sorting strategy, quick sort, merge sort, or heap sort. Now let's see how we are using this strategy design pattern in our Battleship game. So here we can see that there is a game class. For choosing the next player, we are using player selection strategy, which is an interface, and then this interface is implemented by multiple algorithms. So one is random player selection strategy. It will give us the random player index. Then the round robin player selection strategy, and it will give us the next player index. In the same way, this game is using the winning strategy also. So in the winning strategy, there are two strategies: all ships down winning strategy, battleship down winning strategy. In all ships down strategy, if the opponent's all ships are down, then the player will win. And in battleship down strategy, if only the battleship is down of the opponent, then the player will win. So you can implement as many as algorithms you want, but the game will not have to worry about the implementation logic of the algorithm. It will just call the won method by passing which kind of strategy it wants, and then that strategy will perform its task. Yeah, that's all from this video. See you in the next chapter.